Okay, this is a little shortcut for homework 8.4. It's very quick to use this method. And here we're talking about proportions, population proportions, and sample proportions. So what we do is, what's important here is also to be able to do it by hand, but for time purposes, you can use StatCrunch. So it's very similar to how we do z-scores, but there are a few differences. The standard error, instead of it being of the mean, it's the standard error of the proportion. So this part, calculating the standard error of the proportion, is the difference. And you're going to say P plus and P minus. So the proportion plus, the sample proportion plus, and the sample proportion minus. So we're looking at proportions here. So to get the standard error of the proportion, you do the square root of P times 1 minus P divided by N and take the square root of that. So basically, if P is 0.70, then what would be 1 minus P? 0.30. So you're multiplying 0.70 by 0.30. Now, when you multiply those two together, they pretend that it had to add up to 1. Well, if you put 0.30 here, you put 0.70 here. 0.3 plus 0.7 is 1. So when you multiply here, these two numbers should technically add up to 1. In this example, it is 0.70 and this is 0.30. And if you were to add those, they would add up to 1. A proportion should always have a total sum of 1 and nothing over 1. So that's just a shortcut to understand, hey, if P is 0.70, then this is technically going to be 0.30 in the parentheses. If P is 0.20 here, then 0.80 would go in the parentheses. If P is 0.75 here, then inside the parentheses would be 0.25. So then you multiply your difference together. So this is 0.70 times 0.30. Divide that by 550 and take the square root of that. And you get this number here. And then you plug that in. You get your z value for your confidence interval of 0.95. You can look that up, remember, in that table I gave you. But you don't have to do all of this on the homework. Then you would do your proportion, which was 0.70, plus your z value times your standard error, which we just calculated. And then you would do your proportion minus the z value and the standard error. So this is a little bit different because we're using proportions, so our answers are going to be kind of weird looking. But to save you time on the homework, all we need to do is go into StatCrunch. We know our confidence interval is 90%, and we know our sample size is 200, and we know our sample proportion equals 0.50. So how many successes do we have? We have 0.50 times 200. Well, I could go ahead and tell you half of 200 is 100. So to get your successes, you take your sample proportion and times it by your sample size. So I'm going to show you. Those are the three numbers we need: 90%, 100, and 200. Go to stat. We've been going down to z-stats, t-stats. Now we're going to proportion stats. We only have one sample with summary data. So the number of successes, remember, to get the number of successes, you take your proportion sample right here and times it by your sample size. So 0.50 times 200 would be 100. That's how you get that number. And then we have 200 observations because N was 200, and our confidence interval is 0.90, so we need to change that to 0.90, and you hit compute. So our lower limit, let's see what we need to round to. 3 decimal places. Our lower limit is 0.441 and our upper limit is 0.558. 0.441 and 0.558. Oh, let's go back and make sure I entered everything correctly. 0.442 and 0.558. Let's try it and see if that is right. Okay, and that just shows you how easy it is to miss these if you don't round exactly right, and that's what bugs a lot of students about StatCrunch, because they want an exact number. It rounded to an exact number, so you could have worked the whole problem right, but if you have one number off or don't round exactly right, it will count against you. This is a quick way to do these. I would try to do 1 or 2 by hand, but then you can use StatCrunch for the rest. You will have the formula on your test on the formula sheet, so you do need to know how to plug into the formula. But that's pretty much it. You should be able to get through 8.4 fairly